Alright, let's factor number 6. We're asked to simplify each rational expression and then list the restrictions on the domain. Step number 1, I asked you guys to factor using either GCF or Xbox. So let's go ahead and do that here. Teresa, when you factored, pick one, top or bottom? And what did you get when you factored? Do you want to do the X together? Teresa, what is A times C?
7.
Correct. Your B value? Your phones are off. What two numbers will multiply to be 7 and add to be 8? Oh. Raise your hand if you got 7 and 1. Good job. Jonathan? Top?
X plus 7 and X minus 2.
Raise your hand if you got that. Good job. Partner A, tell partner B, what's step number 2? Just read it off. Ready, set, go. Class, what do we have to do? Okay. Do you see anything on the top and the bottom of the fraction that are exactly the same? Okay, so we're going to cancel this. And it says in the parentheses there, if you cancel it, it's called a what? What does it say? Did you guys write it? A removable whole. Okay, so we're going to write a removable whole. This is the restriction on the domain. We're basically listing something that's happening here. So we're going to write x plus 7 equals 0. And then all we have to do here is solve for x. Class, how do I solve for x? Subtract 7. And x is equal to negative 7. Okay, something's going to happen. So when we draw the graphs, something's going to happen there, okay? Okay. Step number 3. The other person, read to your partner, what is step number 3? Ready, set, go. Okay, so once we cancel, we're left with this expression here. Class, what's step number 3? Set the denominator not equal to 0. Question. Do I have a denominator in this problem? Put your finger on the denominator. It's this one. So now, step number 3 is actually telling us this is your vertical asymptote. Your vertical asymptote is you set the denominator not equal to 0. Sounds kind of weird. You may have not seen this math symbol before. But just pretend it's like an equal sign. Class, how do you solve for x? Subtract 1. X is not equal to negative 1. Okay? Let's pick a different color to put this in. Let's use green. Okay? Now go ahead and pull out your phone. Pull out Desmos. For now, we're just going to use technology to get a graph. And then by the end of this week, you're going to be able to sketch these without your calculator. Okay? So you're pulling up Desmos. And I want to prove to you that the original problem and the one in pink is what we're going to graph. They're exactly the same. So I think in Desmos, if you, I think you can graph two different functions. So what I'm going to do is I'm going to type in all of this over here, and I'm going to use an extra set of parentheses. Let me draw those parentheses for you. Let me show you how I would type this in. Parentheses, x squared, so just type xx, plus 5x minus 14, close the parentheses. The fraction line is division, because that's what a rational function is. x squared, so parentheses x squared plus 8x plus 7. Now again, if you're using Desmos, I'm not sure how do you get to a next line. So for my graphing calculator, I'm just going to press down. So I just graphed that one. That's the first function. Mine is going to show up in blue. And then the second one, I'm going to do the same thing. Parentheses x minus 2 divided by x plus 1. So basically I have that as my first function, and my second function is right there. Okay, now I'm going to press graph, and you'll notice the colors. It's first going to graph the blue one, and then the red one. Here comes the blue one, and then here comes the red one. Class question: what happened to the blue graph? Class, do I have a blue graph?
It's exactly the same.
No, it's behind the red graph, which means, like what you just said, it's exactly the same. They're the same graph. So in some ways, the graphing calculator kind of just verified algebraically that these two expressions are the same. Okay? So let's go ahead and now use our calculator to draw a sketch. Straight edge. Straight edge. I have x equals -1. It's okay if you don't have graph paper. So I have a vertical asymptote in green here. This is what I'm drawing. Dotted line. This is at -1. The next one I'm going to draw is this removable hole. Now for the removable hole, I'm going to just draw a line very faintly. And it'll come back to it when we do the graph. Okay? So I have the removable hole. It looks like a vertical asymptote, but it is a restriction of the domain. And then what I'm going to do is I'm going to go ahead and graph this using my technology for now. Later on we'll be able to find the horizontal asymptotes and then just graph it. So I have one here. Okay, what's different is when you approach the blue line, pay attention, you're going to leave a space to put the donut right there. So right where the graph meets the hole, or this blue line, that's where I put the hole. Okay? So let's review what we did. Step number 1, I make sure I factored it. Step number 2, if I cancel it, it's a removable hole. I need to graph it. If I have a fraction, a rational function, set the denominator not equal to 0. That's your vertical asymptote. Use your technology to graph it. And then again, the hole, which doesn't show up on your technology, is where this blue line meets your graph.